Hello students, welcome back to the fourth video of this playlist. So in this video, we will be solving question number 4 from January 2024 Pure Mathematics 2 paper. So let's see what's the question number 4 from this paper is about. So basically the concepts behind question number 4, it's from exponentials and logarithms that has been discussed in chapter number 3 of your P2 Pure Mathematics 2 textbook. And in the later parts B and C, we will be dealing with trapezium rule, integration by trapezium rule, which is discussed in the last chapter of your P2 textbook, which is chapter number 8, integration. Okay, so let's get started with question number 4. Okay, part A. Sketch the curve with equation y equals to a inverse x plus 4, where a is a constant and a greater than 1. Okay, on your sketch, show the coordinates of the point of intersection of the curve with the y-axis, the equation of the asymptote to the curve. Okay, so we need to sketch an exponential curve. Okay, so for all exponential curves, what we know, all exponential curves has asymptotes. What asymptote? Horizontal asymptote, right? Because we know that the exponential values for a to the power x, okay, for a to the power x, or if you consider a to the power x or e to the power x, these are exponential terms, right? Exponential expressions. So these values can never be negative. Okay, e to the power x or a to the power x, these values can never be negative. So that's why always their curves remains on the positive y-axis, and always there is an asymptote at the x-axis, and these values can never be equal to 0. Okay, so that's why always on the exponential curves the asymptote is at y equals to 0, is an horizontal asymptote. There is an horizontal asymptote. There is a horizontal asymptote. Okay, so for a inverse x plus 4, it is basically a transformed curve, isn't it? Transformed curve. So how it is transformed? It is transformed. It is translated along the vertical axis, along the positive y-axis by 4 units. Okay, so that means instead of y equals to 0, in this curve the horizontal asymptote would be y equals to 4, because since all the y values are getting added by 4, so that's why the graph will move, the graph of a inverse x will move along the positive y-axis by 4 units. Okay, so here you go, this is the axis, so horizontal asymptote is at y equals to 4. So let's sketch the asymptote. This is y equals to 4 and a inverse x, right? So a inverse x is what? A inverse x will be like this. Okay, this is y equals to what? A inverse x plus 4. Okay, now they ask for the y-intercept. At y-intercept what? The value of x is 0, then what would be the y value? A to the power 0 is what? 1. So 1 plus 4, this is what? 5. So this is x value 0, y value 5. That's it. So this is what they have wanted in the part A of question number 4. That's it. Okay, next is part B. So part B asks here, okay, they are saying the table above shows corresponding values of x and y for y equals to 3 inverse half of x plus 4. The values y are given to 4 significant figures as appropriate. Using the trapezium rule, look, we need to use trapezium rule with all the values of y in the table. Okay, we have the table. You can see in the uh, above, it's given that in the table the y values, x values are given. So part B asks to find an approximate value for integration of 3 inverse half of x plus 4 from -4 to 8 over 8.5 with respect to dx, giving you answer to two significant figures. Okay, so we need to find the value for this integration, okay, using trapezium rule. So for trapezium rule, what we know, the trapezium rule, the formula for trapezium rule is basically on the basis of the area of a trapezium, isn't it? So the equation says integration of 8.8, integration from 8.5 to negative what, it was -4. Okay, -4. Then equation was, what was the equation? 3 inverse half of x plus 4. Okay, 3 inverse half of x, 3 inverse half of x plus 4 dx. So this is equal to what? The area of trapezium is half of a plus b times h. If I write the area of trapezium here, area of trapezium is basically what? Half of a plus b times h, where a and b are the heights of the parallel sides, and h is the distance between these parallel sides. Okay, so in trapezium rule, what we do, since there will be strips, right? In trapezium rule, we divide the area region into smaller strips and we compare them with trapeziums, isn't it? So we take half of h common from all of the areas of the trapeziums. So half of h is what? The separation between the parallel sides, isn't it? So here, what would be the separation of the parallel sides? Look, parallel sides are like this. It goes like this, isn't it? So since it goes like this, that means the separation will be dependent on the x values. So -4 to -1.5, then 1. Look, it is increasing at a constant rate, isn't it? -4 to -1.5, what's the difference? This is what? 1 point, 2.5, isn't it? 2.5. So each time, what? It's increasing by 2.5. That means the value for h is what? 2.5. The separation between the strips, or the width of the strips, is 2.5. Okay, so h is 2.5, which is 5 over 2, and then we took common, write a second bracket. So in the area of trapezium, the first strip, the first height of the first strip will not have any common, it will not repeat twice, so this is alone. And the last height, the last strip, the last height of the last strip will also not have any what, repeatings. Okay, so that's why we add them separately. uh, that is 13 plus what, 4.009, and then the rest of the heights will get repeated twice because these are the common sides. Okay, common side of two strips. Okay, okay, so these are what, 6.280, 4.577. Okay, let me write them one by one. 6.280, so 6.280 plus what, 4.577, and then plus what, and then 4.146, 4.146, and at last the last one is basically 4.037, 03, the last common one, not the last height. Okay, the last height is 4.009. This is single, that's why we have added it separately. Now just find out this value, you will get the value for the integration. 0.5 times 2.5. Okay, 6.280 plus 4.577 plus 4.146 plus 4.037 times 2. Okay, then plus 4.009 plus 13. So this is what? 55.089 times 2.5 times half. So this is basically what? 68.86125. The value we get 68.18, 68.86125. That much unit is. Oh, this is not the area. This is just value for the integration. So not need to write in unit squared. So 68.862. They wanted to how many significant figures? I guess two significant figures, isn't it? You answer to two significant figures, so in that case it will be what? 69, right? 69 up to two significant figures, and that's what the part B question from question number 4 has asked for. Okay, next is part C. Using the answer to part B, find an approximate value for integration of 3 inverse half x dx from -4 to 8.5. Okay, we need to use the answer from part what? B. Okay, so how can we approach this? Look, we need what? Integration of 3 inverse half of x, right? We need the value for integration of 3 inverse half of x. So this is part C1. For part C1, what we can write? Look, integration, the upper limit they said 8.5, lower limit is, what was the lower limit there? The lower limit is -4, 8.5 to -4, 3 inverse half of x dx. It can be written as what? Look, integration of 8.5 -4, 3 inverse half of x, then it was plus 4, right? Plus 4 dx. The answer of part B, the equation that is in part B, this is plus 4. Okay, from there, what we can, if we subtract integration of 8.5, okay, 8.5 to -4, 4 dx, we are getting the answer. Okay, because from what? 3 inverse half of, we need just 3 inverse half of x, but here plus 4 is the extra, so we need to subtract it simply. Okay, so the value for part B, the answer of part B, we got 68.86125 minus what? Integration of 4, which is which will give you 4x. 4x. So upper limit is 8.5, lower limit is -4. So that would give you 68.86125 minus 4 times 8.5, this is 34, and then it will be plus 4 times 4, this 16. Okay, so this is just 50, exactly 50. So that would give you 18.86125. So how many decimal values they wanted in the answer? Just approximate value. So you can give to 3 significant figures since this is the standard, right? So 18.9. That's the answer for part C1. That's it. Okay. Next is part C2. In part C2, they're asking to find what? Approximate value for integration of 3 inverse half of x plus 4 from 8.5 to -4. It's integration with respect to dx. plus integration from negative 8.5 to 4, 3 to the power half of x plus 4 dx. So you need a bit concept from transformations here. Okay, so in part 2, look, early in the first term there is the power is negative half x, but here it is half of x, but at the same time the the limit has been reversed. Okay, that means it has been balanced out. What did I mean by the word balanced out? Look, this is from negative 4 to 8.5 and this is from negative 8.5 to 4. And at the same time the power was inverse in the previous one, so you can consider the change is like this. It was like that 3 inverse, okay, but now it's like this. Okay, so earlier the area was from negative 8.5, isn't it? Sorry, 8.5, positive 8.5 to negative 4. Okay, but now same, it's from what, this distance, okay, 8.5 to positive 4. So basically the area is remaining the same area, since the curve has been just what, reflected, you can say. Okay, so the area is remaining the same. That means the twice of the answer of part B. The value for this integration is twice of the answer of part B. So twice of the answer of part B, the answer of part B was 68.86125. We got it earlier. Okay, so 68.86125 times what, 2. So this is 137.7225. We can write 138 to 3 significant figure. Okay, so this is what, 68.86125 times 2, which is 1, the exact value is 137.7225, which can be rounded to 3 significant figures as 138. That's the answer for part C2. And that's the end to the question number 4 from January 2024 Pure Mathematics 2 paper. That's it.